Hi everyone and welcome back to another video. So all the questions today were answered fully correctly by less than 5% of students. To get the most out of this video, I'd recommend that you try the questions beforehand by pausing the video, give it a go, and then if you get stuck, watch how I would approach the question and see if that helps. So this is our first question. So we've got a nice little diagram. And it says B, C and D are points on the circumference of a circle with centre O. A, B and AD are tangents. DAB equals 50 and we want the size of BCD. So BCD is this angle here. I always like to mark on the angle we're trying to find. And then at each stage we need to give a reason for our working. So hopefully by now you've realised this is a circle theorem question, so we need to use our different circle theorems. If you're not sure what these are, have a Google and they'll come up, but there's a few different ones. The first one I think we need to use is that tangents to a circle always hit the circle at 90 degrees. So A and B here is a tangent, so where it's hit this radius, that makes a 90-degree angle. And it's the same with this tangent here, A and D. So if we know that this is 90, this is 90, and this is 50, that means we can work out BOD. So what I would say is BOD, we have, this is a quadrilateral, so it'd have 360 degrees in. So we want to minus 90 plus 90 and minus 50. And that will give us an answer of 130. So we know this angle here is 130. So what I would write as well, because it says give a reason for each stage of your working, I would write that angle ABO and angle ADO are 90 degrees because the angle between tangent and radius is 90 degrees. So write that as well. I'm not going to write it because that'll take time, but write that to the side. And then we found that this angle is 130, and you could also write next to it because angles in a quadrilateral add up to 360. Okay, so we've found this angle here. And again, now we need to use another circle theorem. So this one is a little bit more easily recognisable, usually, but it's our circle theorem where we've got an angle at a centre and then an angle at the circumference. So what happens here is the angle at the centre is going to be twice the angle at the circumference. And again, if you've not seen these circle theorems before, have a look at them and it'll make a lot more sense. So if we know the angle at the centre is twice the angle of the circumference, we can just say, well, we'll do 130 divided by 2, and that's going to give us 65. And then we can write our explanation to that, and I would write because the angle at the centre is twice the angle at the circumference. Okay, next question we have express the reoccurring decimal 0.28 as a fraction in its simplest form. Now, for some reason, the reoccurring sign was coming up really dodgy when I was copying the question over. So I actually couldn't tell where the reoccurring signs are, but we're going to say that it's over both of them, and it'll be the same method if you see a similar question like this. Okay, so what we're going to do for these is we're going to say, well, x equals 0.28, 2, 8, 2, 8, and you can write that for as long as you want, but don't waste too much time. And then we're going to say, well, 10x must therefore be equal to 2.8282, etc. Now, what we are aiming for is for these lines to line up with the numbers, so we want 2 2's, 2 8's, 2 2's, etc. So we can see that 10x isn't going to work, so then we could say 100x. And if you can see that straight away, you can just jump to 100x. But that would give us 28.28282 8. So here you can see, ignoring the 10x now, we don't need that one anymore. So kind of cross that out. We can see that our 2's line up, our 8's line up, 2's line up, our 8's line up, etc, etc. So what we're going to do then is use our 100x and we're going to subtract x from 100x. And because they're both reoccurring, we end up with 99x is equal to 28. So to find our fraction, we say, well, x is equal to 28 over 99. And that's your fraction. Now, like I said, I don't know what the actual original question was, but if it was 0.28 with them both recurring, that would be your answer. Okay, so next we've got this nice graph here. This one was only answered correctly by 3.3% of students. So let's see why 96.7% of people didn't get full marks. So we've got, the diagram shows the graph of y equals x squared minus 5x minus 3. Use the graph to find estimates for the solutions of the simultaneous equations y equals x squared minus 5x minus 3 and y equals x minus 4. Okay, so the words we need to be looking for here are use the graph. So we know that we don't want to solve these simultaneous equations algebraically. If you wanted to go back and check, you could probably solve them algebraically later, but we're not going to get any marks for doing that. So they've nicely plotted this curve on the graph, but we need to plot y equals x minus 4 on the graph. So the way I like to plot things is by doing a little table. So we'll say y, we have y, and we have x. So I usually do, well, we've got -3 to 7. So if x equals -3, what would y equal? So we pop it in our equation. So we've got y equals -3 minus 4. So in that case, y would be equal to -7. And then we've got if x equals, say, -1, y would equal -5. If x equals 0, y would equal -4. If x equals 2, y would equal -2. If x equals 5, y would equal 1. So we've got a few coordinates there. You don't need to plot them all, especially if you know it's going to be a straight line. So we've got -3, 7, 1, 2, 3. We want about 2.5. It's important to do these right when we're using the graph to estimate. So we've got -1 and -5. It's a bit hard on a computer screen. -4. X is 2, y is -2. And if x is 5, y is 1. Perfect. So what I would then do is use my ruler, connect these dots. Now this line is a bit too thick, but anyway, we'll go with it. And then to find the answers to the simultaneous equations, you want to look here, where these lines cross, and here, where these lines cross. So we've got here, if we draw a little, let's get another line. So if we draw up from this point where they cross, I'd say we've got x equals like 0.3. Like I said, my lines are a bit thick, so if you were doing it with proper sharp pencil, it'd probably be a bit more accurate. And then we've got y equals -4. But you get the point. So not -4, not 0.4. And there would also be some leeway in the question. So you would have a range of answers that were acceptable. And then we've got here, so we could have x is equal to like 5.8, would we say? And y is equal to about 1.4. Like I said, it's probably not quite right. This line's a bit thick. This one is probably a little bit less than -4, but if you do it with a pencil carefully, and there will be some leeway in your exam. Okay, so on to the last question. We have make t the subject of the formula. So, to do this, if we've got a fraction, I always like to times up by the fraction. So we can do p times 4 plus t is equal to 3 minus 2t. We then want to expand this bracket, so we've got 4p plus pt equals 3 minus 2t. We then want to get all the t's on the same side and everything else on the other side. So I would add 2t, so we've got 2t plus pt, and I would subtract 4p off, so we've got 3 minus 4p on this side. And then we want to take t out as a factor. So we've got t, 2 plus p equals 3 minus 4p. And then finally, we're just going to divide by this bracket. So we've got t is equal to 3 minus 4p divided by 2 plus p. And that's your answer. If you've got any questions, pop them in the comments, and I have lots more videos like this coming up soon, so hit that subscribe button. Thank you very much for watching.